Hi, welcome to Omnivision. Today I have with me three wonderful guests. I have Jacob Holloway here on my left. He's a recent graduate in agriculture economics. On my right, I have Dick Bennet. He's the founder of the OMNI Center and retired professor of English. And also I have with me Dr. Stephen Boss, the director of Environmental Dynamics at the University of Arkansas and also a professor in geoscience. And today we'll be talking about the Gulf of Mexico oil spill, why it happened, and sort of some of the concerns associated with that, and what we can do in the future maybe to help prevent these kinds of disasters. And I'd like to start off by allowing Dr. Boss to help explain sort of why this kind of event occurred.
All right, yeah, thanks, Abel. Well, this is actually, I think a very significant event in the Gulf of Mexico. As we all know, this is turning into a very significant oil spill. It's going to end up being one of the most significant ones we've had in the Gulf of Mexico in the history of oil drilling there. And it is, from what we understand right now, a lot of the details of this are still emerging, but from news accounts and from eyewitness accounts that we've seen recently emerging from some of the news broadcasts and whatnot, I think we're beginning to piece together what really happened and transpired in this. And it's not an unlikely event to occur in the kinds of depths of water and the depths beneath the subsurface where they've been drilling and trying to tap into these oil reserves in the Gulf of Mexico. It is actually a preventable disaster, and so I think it's pretty clear as time goes on that we will find out there were a number of human errors that occurred along the way here that led to this final event. But I think one of the things I'd like to talk about, and I've had a lot of questions about this in the last few weeks, as you can imagine, and one of the things that comes to mind quite often from lay people asking me questions about it is how is it that this oil continues to flow out of the oil well at the bottom of the ocean here.
Some people are calling it an oil volcano because it's not really a spill. I mean,
yeah, well, that's right, and it's actually, I think in the old days, these would have on land, they would have been called gushers, when the oil simply free flows out of the borehole and comes out for a long time. And I think that's what people need to understand about this is that the forces at work here are quite tremendous and really sort of unimaginable on human scales.
You said it was like 200,000 gallons a day coming out?
I think that's the estimate we've seen. The most common estimate we've seen is that it's flowing out about 200,000 gallons per day. That's 1 million gallons every 5 days that are coming out of this well. And if you do some quick math, it's almost 10,000 gallons per hour coming out of a borehole that's about 24 inches in diameter on the seafloor. So it's a tremendous quantity. So it's a tremendous quantity of oil coming out very, very fast. And one thing that we need to understand is what drives this oil out of the ground. They're drilling at a depth that's almost a mile beneath the surface of the ocean to the seafloor. So you have a mile of water overlying the seafloor here, and the pressure of that water alone is tremendous in and of itself. But then they're drilling another almost 3.5 miles beneath the seafloor into the formations where the soil is held. So the pressure at that depth is really tremendous. It's thousands of pounds per square inch.
They said that maybe the methane gas contributed to this explosion?
That's right. Well, there's a lot of methane. Always there's a lot of methane associated with oil in the subsurface of the earth. And it's not entirely clear what transpired on the well, but they were involved in a process.
I heard that like Halliburton was involved in doing some concrete work like 20 days before this.
Right. Well, that's right. When they drill an oil well, a deep well like this, they have a drilling stem that goes down with a drill bit on the end, and it drills a hole into the earth, a borehole. And then after that borehole is completed, they have to actually insert a pipe called casing that goes down, and that prevents the borehole from collapsing.
So was this a relatively new project, a well?
This well was pretty new, and it's in relatively deep water.
Happened under the Obama administration, I understand, is that right?
I don't know when exactly they began drilling on this. Probably they've been out there for a few months, I suspect. I mean, it takes several months to complete a well like this. So I don't know exactly when they began. But the technology, the drilling technology is not particularly new. I mean, this is how we complete wells and how they've been completed for decades. But so you have to insert a steel casing, which is just a pipe in itself, into the borehole to prevent the borehole from collapsing. And then there's always a little bit of a gap that exists between the outside wall of the casing and the borehole itself. And you have to seal that that space so that material doesn't leak up gas or oil, doesn't leak up on the outside of the casing. You want all the gas and oil to come up through the inside of the pipe so that you can control the flow rate. So they cement that in place. They inject cement into the borehole and then fill that gap that exists between the outer wall of the casing and the borehole itself with cement and cemented in place. So that holds everything firm, and that allows the oil or the gas to flow up through the pipeline where they can control it directly. And my understanding is they're in the process of cementing this in, and then following the cementing, they remove the drilling fluid from the borehole itself that they use, and they replace it with seawater, and then they can begin production after that time once they bring a production well on site. And it was something in a transition that went on where this got away from. Now again, the pressures at the bottom of the borehole are tremendous, and so you've really got to keep a very careful eye on what's going on downhole. And they know this because they have pressure sensors down in the borehole, and they understand what's going on. And when they see things getting away from, there's a variety of things they can do. They can add more drilling fluid to the borehole. They can change the density of the drilling fluid to keep the pressure on so that the stuff doesn't blow back out through the hole. And unfortunately, that didn't happen in this case.
Oh, I was just curious. I'd heard different, ideas put out there as far as like putting a giant concrete dome over this place right now. Where
we just had a report that failed, right?
Did that actually fail?
Yeah.
What was the technological problem with just putting something over it? I heard one engineer explain that there was a lot of pressure there, and that there would have to be a carrier fleet of cargo ships to actually release the pressure from this. What was the problem? Why didn't that work?
Well, again, this oil is coming from 3.5 miles below the bottom of the ocean, plus a mile of water on top. It's 4.5 miles beneath the surface of the ocean, and the pressure at those depths is tremendous. And that pressure is squeezing on the rock formation that contains the oil, and you have a very narrow conduit,
pushes it up,
only 24 inches. You've got a pinhole basically in the surface of the earth that allows that oil to get out, and it's all coming out through that one conduit. And it's coming out very fast. It's flowing out at a rate of something on the order of 10,000 gallons per hour. I mean, it's a remarkable quantity of flow. And so it's very difficult to stop this. And once it's on, it's free flowing right now, and you can't just stop it.
Before the show, you helped to explain sort of why this concrete dome, this was like their best solution that they could come up with. There obviously aren't any grid solutions at these kinds of conditions, but you helped explain why that failed.
Yeah, well, the idea initially was to put a lid, basically a large lid over the top of this oil, and then have a pipeline that would go to the surface that would, as the oil leaked out into this large concrete and steel box, they would pump the oil up to the surface, and then it would actually be put onto a ship, and they'd offload it and take it away. One of the things that happens at these water depths, the temperature at the bottom of the ocean is relatively cold. It's probably not far from 0 degrees C. It's probably 2 or 3 or 4 degrees C. I don't know the temperature at the depth, but it's pretty cold in that depth. And at the pressures and temperatures that you see there, methane that's also escaping with this oil will complex with seawater to form a solid phase called a gas hydrate or a clathrate. And gas hydrates are essentially methane ice. It's methane complexed with seawater. It's a solid substance. And as that methane ice forms, it clogged up the conduit for the oil to get out through the pipeline. And so simply just clogs the thing up, and so the oil couldn't flow through this. And the methane hydrate itself is very dangerous. If that methane hydrate gets carried to the surface, once it gets to the surface at normal surface temperatures and pressures, it will flash to gas phase from the solid phase, and the volume expansion is tremendous from that. And that's really kind of how you can get another large explosion from this. So you get a lot of methane that will evolve from these solid phases, and you get the potential for even bigger explosions.